Okay, so I'm going to talk about the basic physics equations, which you learn, when you're pretty young in life, but you don't know that we're actually using it in real life at this time right now. So let's say that you have a car and the car is traveling. Say doo doo doo, you have a car and the car is traveling at 40 miles per hour. We always say that, oh, you know, it's traveling, this car travels 50 miles per hour, or da 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 da, please pull you over for going 55 miles per hour, etc., etc. This is the speed of the car. We call it the speed. And is, what this means is it traveled 40 miles in 1 hour. This is a ratio of how many miles per hour you go. So if you just look at a graph, let's say we look at a graph, hours and miles, and that means that 40, 80, etc. Every hour it moved 40 miles. Do 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 do. So this means that let's say that a car is moving 40 miles per hour, how long would it take how far would it go in 6 hours? Well, we know that in 1 hour you travel 40 miles, so in 6 hours you travel 40 times 6, which would be 0, 24, 240 miles, right? So if you're traveling 40 miles per hour, in 6 hours you travel 240 miles. So let's make some sense of this equation. And this is the speed equation, or I guess you could say kind of velocity. It's a little different, but you'll learn about that a little later on. But this is one of the basic equations. And the equation says that the speed is equal to the change of distance over the change of time. And I have df di is change of distance and tf ti is change of time. And you can write this any other way. Sometimes people write it as d2 minus d1 over t2 minus t1. It all means the same thing, change of distance over change of time. This means that for my car that's moving 40 miles per hour, that means that it starts off, for this car, it starts off at 0, and then you speed up, and you go up to 40 miles in 1 hour. That means that it starts off at the final speed. D2 is the final speed. The final speed is 40, and it starts at 0, over, this is all miles, over the final time, which is 1 hour, minus the initial time, which it starts off at 0, hours. And if you solve this, 40 minus 0 is 40. 1 minus 0 is 1, so you have 40 miles per hour. It gets a little tricky, though, when you have to try and figure out how fast, what was the speed of it when it doesn't start at 0. Let's say that a car is driving and you start timing it at 1 hour. And you time it at 1 hour, and then it goes to 3 hours. And at 1 hour, it went 20 miles. And at 3 hours, it got to 40 miles. And you're like, what's the speed in this little area? Right? In this little area, looks like that. What is the speed of it? And first thing you do is take this equation. The velocity is a change of distance over time. So if you want to think of velocity or speed, if you want to think of speed, think of cars, miles per hour. The distance over time is, the distance is miles per hour. Hour is time. So if you want to use this, we could look at the d2 minus d1 over t2 minus t1. And this is the speed, or I'm going to write v for speed. Okay, so the final distance is right here, right? We stopped at 40, so d2 is going to be 40. d1 is going to be the initial, and we started timing it at 20 miles. So minus 20 over. Remember, it's always the later on, the final distance minus the initial distance. The final time was 3 hours. This whole thing is miles, so you don't forget. The final time is 3 hours minus 1 hour, right? The final time is 3 hours, and the initial time is 1 hour, because that's when we started timing it. Yeah, 1 hour. So when you actually solve this, 40 minus 20 is 20. 3 minus 1 is 2. This moves 20 miles per 2 hours. And of course, when we use cars, we normally do per hour. We don't do per 2 hours. So we're going to divide top and bottom by 2. And what this does is it makes the bottom 1, it makes the top 10, right? This means that the car is moving 10 miles per hour. So this area right here, the car is moving 10 miles per hour. So now that we have this, we can start doing some other things with this graph or this equation. So I'm going to rewrite this equation real fast. Remember, it's going to be d2, the final, minus d1, which is initial, over the final time minus the initial time. Okay, so using this, we could simplify this to say that the speed is equal to d over t, right? Now we can move stuff around. We can multiply both sides by t, right? T's cancel, because t over t is equal to 1. So you actually get d times 1, which is equal to d. So that's what happens right here. T over t cancels, it turns into 1. So all you're left with is Vt equals d. This means that the speed times the time is equal to the distance. So let's see if this works. So, and remember, you could figure this, you can memorize this equation just by doing this. V equals d over t. Multiply both sides by t, and you get Vt over d. And that's how you can memorize this equation. You're just moving these letters around. Okay, so let's see if this works, right? So let's say that my car is moving 3 miles per hour. And I want to know how far did it move in, I don't know, 6 hours. So if my car is moving 3 miles per hour, how far did it move in 6 hours? Right? And this is basically this equation right here. Because v, the speed, is equal to the distance over time, right? So let me solve for d, and I use this equation right here. Vt equals d. And this means that the speed, 3 miles per hour, times the time, which is 6 hours, equals d. And this equation is pretty interesting because when you actually multiply it, this is what happens. 3 miles per hour times 6 hours equals d. The hours cancel out. Hour on top, hour on the bottom. Just like how if I was to do 3 times 5 over 5, 5's cancel out. Hours cancel out. So you're left with 18 miles. Which makes sense, right? If I'm moving 3 miles an hour, in 6 hours I moved 18 miles. I mean, it makes a lot of sense. So let's say that we move this equation even more. Let's do this real fast. And I have v equals d over t. I multiply both sides by t. And I get Vt equals d, because these c's cancel. And let's say that I want to find time, so I divide both sides by v. And these v's cancel, and I have the time is equal to the distance over speed. Now let's see if this works, right? Um, how long does it take for a car to move 30 miles? So 30 miles. If the speed's 10 miles per hour, and we're trying to find how long does it take. Okay, so this is a pretty interesting thing to think about. So let's say that the time equals the distance is 30 miles, right? And the velocity, the speed is 10 miles per hour. Right? Miles cancel out, mile over mile, and all you're left with is hours. So 30 divided by 3 is 3. 30 divided by 10 is 3. So in 3 hours, it moved 30 miles when it was going 10 miles per hour. So this is not all of the equations, right? We have some more. Now, what is the acceleration of a car? The acceleration of a car is the acceleration is how fast does it pick up speed, right? That's what we always see in cars. Like if a car has a lot of acceleration, it gets really fast. It gets really fast, really fast. It's kind of funny. So that means that acceleration is good. What this means is that it has a lot of speed in a short amount of time, which makes sense, right? So that means that acceleration is equal to the speed over time. And that's the best way to think of it is in cars. When a car has a lot of acceleration, that means it gets a lot of speed in a short amount of time. And the car's speed is miles per hour, right? So that means that if a car is accelerating, that means that the velocity is increasing, right? So let's see. Let's think about acceleration really fast. So let's say that a car goes from 30 miles per hour to 15 miles per hour in 1 hour, right? So just like how we have the change of distance over change of time, we're gonna do change of velocity over change of time, and we're gonna use this in real life. Okay, so I guess I can move all this, and so that means that acceleration is v2 minus v1 over t2 minus t1. The change of speed over time. So using this problem that we're looking at, if a car goes from 30 miles per hour to 15 miles per hour in 1 hour, this means that the final acceleration is 15 miles. The final speed, 30 miles per hour, 15 miles per hour. So that means that it went from 30 miles per hour to 15 miles per hour. So the final speed is 15, and the initial speed is 30, right? 15 to 30 over the final time is 1, and the initial, it starts off at 0. Oof. So it went from 0 in 1 hour. It went from 30 miles per hour to 15 miles per hour. So let's look at this. Because the final is 15, the initial is 30, minus being subtracted. So 15 minus 30 is a negative 15 over 1. So that means that the speed is decreasing 15 miles per hour. So the car is actually hitting the brakes, or it just started slowing down. So let's look at acceleration really fast, and let's understand what's going on with acceleration. So what if a car is picking up speed, and then it stopped picking up speed and it's holding the same speed, right? Let's say that in 1 hour it went from speed. so it's moving at 30 miles per hour, and then it hits 50 miles per hour in 2 hours, and then from 2 hours to 3 hours, it's still 50 miles per hour. And what's acceleration? And if you know anything about cars, you know that if the car is holding a constant speed, it has no acceleration. It's not increasing speed or decreasing speed. So let's apply this to this formula, right? So acceleration is the final speed minus initial speed. The final speed is 50, and the initial speed is also 50. Over the change of time, well, the time went from 3 hours to 2 hours, right? The final time is 3 hours, and the initial time is 2 hours. So then you end up with 0, the speed, over time. 0 speed over time. This means that the acceleration had 0 speed. 0 acceleration. There was no acceleration. It wasn't picking up speed or lowering speed, which makes sense because it stayed at 50 miles per hour for an hour straight. So finally, we're going to break down the acceleration. We're going to break down what acceleration is. Alright, so we know the acceleration is the velocity, the speed over time. If you move t to the other side by multiplying both sides by t, these t's cancel, and you're left with acceleration times time is the velocity, or the speed. So if a car is moving it's accelerating at 3 miles per hour in 1 hour, that means that the speed was 3 miles per hour. Right? If it was picking up speed for if it had a 3 miles per hour acceleration over 1 hour, it was actually moving 3 miles per hour. And we're going to finally move this one more time, and we're going to divide both sides by acceleration. What happens is that accelerations cancel on this side, and you have times equal to velocity of acceleration. This is the basics of So let's talk about the units really fast. The units for this, right? So velocity or speed is equal to miles per hour, right? Oh my god, he's moving miles per hour. Oh my god, he's moving 30 miles per hour. That car, that car is, the speed was 10 miles per hour, blah blah. Acceleration is a little different because it's v over t, right? Speed over time, and this is miles per hour over hours. And now you're like, whoa, well, what can this possibly be? Well, hours over hours, this turns out to be miles per hour squared. Miles per hour squared, that's acceleration. Which makes sense, because remember we said that acceleration times time is speed. Remember this? So that means that that miles per hour squared, because it's acceleration, times time, which is hours, right? Only one of the hours squared cancels, and you're left with miles per hour, which is the speed. This is a brief introduction into acceleration and velocity. So I have some more videos coming out.